Okay, 1B, change in arithmetic and geometric sequences. So a geometric sequence is any sequence with a constant ratio between consecutive terms. With a starting value A and a common ratio R, it is in the form of A times, A times R, comma, A times R squared, comma, A times R cubed, comma, and it keeps going to A times R raised to the n. So in examples like 4, 8, 16, 32, 64, we can see that the starting value, our first term is A, so it's 4. And then each time we're multiplying by 2, so that is our R, that's our common ratio, so that's where we got our 4 times 2, and it's raised to the n. All right, so the general form and common ratios. It says the nth term, the general term of a geometric sequence with the first term a sub 1 and common ratio r is a sub n is equal to the first term times that common ratio raised to the n minus 1. Geometric sequences have common ratios between consecutive terms. So when we were doing arithmetic, remember we were looking for what we were adding or subtracting. Here we're looking for what we're multiplying or dividing, okay? So to find that common ratio, we can take the second term divided by the first term, the third term divided by the second term, any term divided by the term in front of it. All right, each term in a geometric sequence can be obtained recursively from its previous term by multiplying by r. So that's that common ratio. All right, so the general form is g sub n is equal to g sub 0 times r raised to the n, or the kth term formula is g sub n is equal to g sub k times r raised to the n minus k for any g sub k, for g sub k is the kth term. All right, so example 9 says determine whether each sequence is geometric. If so, find the common ratio. So how would we get from 3 to 6, 6 to 12, and 12 to 24? Well, if I divide each of them, 6 divided by 3, 12 divided by 6, 24 divided by 12, any of them, I get 2. So yes, this is geometric. Probably should put that maybe up here. Yes, it's geometric. Our common ratio is 2. And he didn't tell us to find it, but let's go ahead and start working with our equation. So a sub n will equal our first term times our common ratio raised to the n minus 1. All right. Same thing here. We notice that we're multiplying by -3, so we know it is geometric. We know our common ratio is going to be -3, but if we're unsure, remember it's the second term divided by the first term. Same as the third term divided by the second term. Same thing as the -81 divided by the 27, and that's -3. So when I go to write my general formula, a sub n equals my first term times my common ratio raised to the n minus 1. All right, for C. So how would I get from 1 to 5, 5 to 9, 9 to 13? Well, that one's not easy for me to see, so I'm going to check. So my common ratio would have to be the second term divided by the first term, which 5 divided by 1 is 5, which should be the same thing then if I took the third term divided by the second term. But 9 divided by 5 is not 5. Therefore, they're not equal, which means this one is not geometric. Okay, so not geometric. All right, and then let's check D. So this one, notice we're dividing. Now remember, dividing, well, let me go on. So if we go from -48 to -12 to 3, we can tell we're dividing by 4. But with geometric, remember, we're multiplying. So dividing by 4 is the same as multiplying by -1/4. So, and if you're unsure, remember, second term divided by the first term. Third term divided by the second term. Either way, when I reduce these, I get -1/4. So then I know my equation, a sub n is equal to our first term, which is 48, times the common ratio raised to the n minus 1. All right, example 10. says find the indicated terms of the geometric sequence. It tells me find a sub 6 and a sub n for geometric sequence 3, negative 15, 75, etc. All right, well, it's going to be easier. We find our a sub n first. So remember that a sub n, we've been doing this, is equal to the first term times the common ratio raised to the n minus 1. So we can see our first term is 3, and our common ratio, so 3 to negative 15 to positive 75, is going to be negative 5. Remember, if you're unsure, negative 15 divided by 3. So we get a sub n is equal to 3 times negative 5 raised to the n minus 1. So there's our a sub n, and then it said, and find a sub 6. So then we're after a sub 6, so notice the only difference is our n becomes a 6. Same thing on the other side. So I got 3 times negative 5 raised to the 6 minus 1. So I'll just plug that in. Or 6 minus 1 is 5, negative 5 to the 5th times 3. It ends up, it gives me negative 9,375. Now B takes a little bit more work here. It says determine R and a sub 1 for the geometric sequence with a sub 4 equal to negative 8 and a sub 11 equal to 1 over 16. So we have two different equations there. So my first one tells me a sub 4 equals negative 8. And so I know n is 4, a sub n would be negative 8. I just don't know the first term or the common ratio. So I'm going to go ahead and set up my equation though. So using that same equation we did on a sub n equals, so negative 8 equals, we don't know a sub 1, we don't know r, raised to the n minus 1, so it's 4 minus 1. And so I can simplify that. I get negative 8 equals a sub 1 r cubed. All right, I'm going to stop there for a minute. I'm going to go look at that a sub 11 equals 1 over 16. So same thing. So I know my a sub n is 1 over 16 equals, I don't know a sub 1, I don't know r, but I know n is 11 minus 1. And so I know 1 over 16 equals a sub 1 r to the 10th. Now, I can solve one of these for a sub 1 and plug it into the other equation. So I'm going to solve the first one here for a sub 1. So I'm going to divide by the r cubed. And so now a sub 1 is equal to negative 8 divided by r cubed. Now I'm going to take that and I'm going to plug it into the second equation over here. So I got 1 over 16 equals, we know a sub 1 is now negative 8 over r cubed times r to the 10th. So that's 1 over 16 equals negative 8 r to the 10th over r cubed. We can simplify these r's. Remember, we divide, we subtract the exponents. So I'm going to divide by negative 8. So that gives me negative 1 over 128 equals r to the 7th. Whoops. And then I want to take the 7th root, and so our calculator can do that for us. Or we can use our factor tree. Either way, I'm taking the odd root of a negative number, so I know it's going to be negative. The 7th root of 1, any root of 1 is 1, over the 7th root of 128 is 2. And so if nothing else, if you can't use a calculator, remember, use your factor tree. 128 is what, 2 times 64? And 64 is 8 and 8. 8 is 4 and 2. And so 4 is 2 and 2. Bring down all my extra 2's. 1, 2, 3, 4, 5, 6, 7. So 7 of a kind. So I know the 7th root of 128 is 2. So I end up with my r is equal to negative 1/2. Once you find r, then come back up here to this other equation and plug it in so you can find a sub 1. And so we know a sub 1 is equal to negative 8 divided by r, which is negative 1/2 cubed. Work that out, and we get that our first term, a sub 1, is equal to 64. Now, I know we're not supposed to box it, but I'm going to do this so you can see what I have here a little easier. So we found our first term and we found R. All right, example 11. It says when a radioactive substance decays, the amount remaining will form a geometric sequence when measured over constant intervals of time. The table shows the amount of an unknown substance initially and after 2 hours. Find the amounts left after 1 hour, 3 hours, and 4 hours. Round your estimates to the nearest gram. So notice they gave us at the very beginning and they gave us at 2 hours. So if I want to find, and it's geometric, if I want to find the number in between, we're going to use what they call the geometric mean, okay? And so, thought I saw that somewhere, but I guess I didn't. So the geometric mean means we're going to take the square root of the other two next to it being multiplied. So, first thing we're going to find is the geometric mean. And so for a sub 1, that's going to be the square root of the 1320 times the 384. So when I do that, I get approximately 711.75. And so everything's in whole numbers, so I'm just going to go ahead and put that is approximately 712. Now once I have that, I have enough that I can find my ratio. Okay, so I know R is equal to that 712 divided by the 1320. And so it's approximately 0.53939 repeated. So I'm just going to say 0.539. I'll go ahead and use the other. That way my numbers aren't off because I used it when I did my answer key. And then I can go through and I can find my A sub 3 and my A sub 4. All right, so I know that nothing else. The way, remember, geometric works is it's a previous number times the R value. So if I take 1320 times 0.53939, I should get about 712. 712 times 0.53939, that should give me about 384. And so A sub 3 should be 384 times 0.53939. And so I got like 207.13. And then A sub 4, I'm going to multiply that times 0.53939, and I got 111.65, which is about 112. All right, example 12. It says you are offered a starting salary of $37,500 for the first year with an annual increase of 5% per year. This means your salary will be 1.05 times what it was in the first year. What would you expect to earn on your 5th year on the job? All right, so our first year, we'd expect to get that $37,500. Then the second year, we would get the $37,500 times 1.05. And then the next year, we get the previous year's amount, $37,500 times a 1.05 times another 1.05. And we could keep going from there. So what we see is, remember, we can rewrite this then, 37,500 times 1.05, and it's there twice. All right. So we can come up with a general equation here. My A sub n is equal to my first term times the common ratio, which is going to be that 1.05 raised to the n minus 1. And so if I want the 5th year, I'll work that out. And I should end up with $45,581.48. All right, a Christmas tree farm has 10,000 trees on its property in 2022. Each year, after 10% of the trees each year after 10% of the trees are harvested. A says write a general formula, T sub n, that gives the current number of trees on the farm in the year n, where n equals 0 corresponds to 2022. All right, so T is going to be the number of trees. So we know that in T sub 0, that first year in 2022, that there are 10,000 trees. And so my equation, T sub n, will equal, if they're harvesting 10% of the trees, that means they're leaving 90% of the trees, right? So there's 90% of the trees from the previous year plus the 700 that they are planting. They're missing some information here that's on my notes. Okay, so let me go back. That's why. Example 13. It should read, a Christmas tree has 10,000 trees on its property in 2022. Each year, after 10% of the trees are harvested, and 700, I forgot this part. That's why it wasn't making sense. And 700 new saplings are planted. Okay, so that's where we got this. So let me go back now. So we know if 10% are harvested, that means they're leaving 90%. So 90% of the previous year, that's what that T sub n minus 1 is. Okay, that's the amount that's left. And this is what they're increasing by because they're planting the new ones. Okay, so they're increasing it by 700. So there's our general form. B says use the formula from part A to find the number of trees for n equals 1, 2, 3, 4. What is happening to the rate of change of Christmas trees over time? So we know in year 1 that if we take 90% of the 10,000 plus 700, we're going to end up with 9,700. And then we're going to take 90% of that plus 700, and that's going to give us 9,430. And then we're going to take 90% of that plus 700. That's 9,187. Then 90% of that amount plus 700 gives us this. So there's our years 1, 2, 3, and 4. All right, what is happening to the rate of change of Christmas trees over time? So it is decreasing, right? But what about the rate of it? How far is it from 9,700 to 9,430 to 9,187 to 8,968? Each time the amount is decreasing by what it's decreasing. So over time, the number of Christmas trees is decreasing. At a decreasing rate. Okay, so we know it's decreasing, but each time it's decreasing by a smaller amount. So what's happening is they're taking away a smaller amount of trees each year. So even though the number of trees is decreasing, okay, so if we graph this, it's going to be going down. But each year, it's getting a little less. Okay, so we'll talk about concavity later, so they're kind of building up on that right there. All right, example 14 says, a ball is dropped from a height of 30 feet. Each time it hits the ground, the ball bounces up to 0.8 of the previous height. Complete the table below to model the data in the scenario. Round your height to the nearest hundredth. All right, so the first bounce is 30. It's going to go 0.8 of that. So 0.8 times 30 is 24. Times 0.8 is 19.2. Times 0.8 is 15.36. Times 0.8, 12.29. Times 0.8, 9.83. Times 0.8, 7.86, times 0.8, and I got 6.29. Now it says, how high will the ball bounce up to after it strikes the ground for the 9th time? Oh, nth time. I can't read. I'm sorry, nth time. So it's just looking for the equation. So we know our a sub n equals our first term times the common ratio, which is at 0.8, to the n minus 1. C says, how many times will the ball need to strike the ground before its bounce is less than 1 foot? Well, so I know the equation, and I want to know where is it less than 1 foot. So what we can do here is we can plug this into our y1, plug this into our y2, and find its intersection. All right, so when you do that, you're going to find your y value at the intersection is going to be that 1, but it's the x that's important. So the x, so y1 equals, type in that equation, y2 is 1, second, trace, intersect, find where they intersect, hit enter, 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 and you should get 16.24219 something. And so it's going to be 17 times, okay, for it to be less than 1. At 16, it's still above 1 because sometime between 16 and 17 is where it hits below 1. So it's 17 times. D says, what is the total distance the ball travels in the first 10 bounces? Note, be sure to consider the behavior of the bouncing ball. So it's dropped from up high. So it's going to go down that 30. And then it's going to go up 24, and it's going to come down that 24, okay? So it's 2 times the 24, looking at my table. Then it's going to go up and down the 19.2, so it's going to travel 2 times that amount, plus 2 times the, what's the next one, 15.36, plus 2 times 12.29, plus 2 times 9.83, plus 2 times 7.86, plus 2 times 6.29. Now that's only going to get us to 8 bounces, and it wants 10. So I'm going to keep going. So plus 2 times, remember the next bounce is 80% of that. So 6.29 times 8. I'm sorry, 6.29 times 0.8, and I got 5.03. Plus 2 times, and we're going to take that 5.03 times 0.8, and I got 4.03. So if I add all those numbers, it's going to tell me how far it traveled in the first 10 bounces. And so I add them all together, and I got 237.78 feet. And that is all for lesson 1.